Hello, can you hear me?
Yes, I can hear you.
Today we begin from where we stopped last time. Let me show you the announcement. I always recommend that you read all my announcements. Let's see. Okay, I can share this with you. Yeah, so the announcement for the week. This is week 3. Just 1 minute. Floyd, who's Floyd? Yeah.
Michael Jordan.
All right, let's see.
Brother, all your teachers foreign. Bro, it's
All right, look at the announcement for the week.
oh, that's good. Cause
please can you mute yourself?
every single math class I've had, or like,
Hello, can you mute yourself, please? Yeah. All right. So this is the reading. We'll be finishing chapter 2 today, and then we start chapter 3. For the assignments, there are 4 of them due this week. Actually, 3, because homework 3 is due next week, not this week. And I may still extend it to another week to make sure that we finish everything before, depending on how far we've gone, So you have classwork 3, homework 2, homework 3, and then Excel assignment 1. Of course, you know that you can access this by going to the models and then scrolling down to model 3. So you can see the classwork. I'm going to put it here after we finish tonight. I'll put it here. And then homework 3, like I said, I put it here so that if you want to start early, otherwise I would say don't start it, don't do it yet. The one that you need to finish up is homework 2, which is this one from the last week, which is due this weekend. And then homework 3 and homework 4 just don't, they're just there for, if you want to start early, fine. But otherwise, just focus on classwork 3, Excel assignment 1, and finishing your homework 2. Excel assignment, let me open it so you can see how it looks. So I have a video for you. Just follow the directions here. Watch the video first. Then you do your own and then upload. Remember, to get credit, you have to upload the Excel file so I can see what you did and how you did it. Having said this, we can now begin finishing up chapter 2, which is from the other types of charts. We finish the rest of the chart that we haven't done from last week, and then we dive into chapter 3, which is data description. So the other types of chart we'll be looking at here includes schema leaf plots, dot plot. We're not going to do dot plot. I'm not going to ask you a question on dot plot, so we're not going to worry about that. Pie charts, bar charts, Pareto charts, and then time series graph. Let's start with the stem and leaf plot. Unfortunately, Excel doesn't have the capability of drawing a stem and leaf plot, so you have to be done manually. Stem and leaf plot actually serve the same purpose as the histogram, except that in the stem and leaf plot, the actual data values are retained when showing them graphically. That's the difference. So let's start with an example. Look at this example here. This question here, it says, the Cornell Lab of Ornithology. Give me 1 minute. Let me put these people in. The Cornell Lab of Ornithology holds annual Christmas bird counts in which bird watchers at various locations around the country see how many birds, how many different species of birds they can spot. Here are some of the counts reported from Texas in the 1999 event. You can see the list of the numbers right here. And the question goes, create a stem and leaf plot to represent this data, and then write a brief description of the data. To solve this, the first thing is to, an easy way to do it is to, first of all, put them in order, arrange them in order, in ascending order of magnitude from the smallest to largest. Then next is to identify your stem and their leaf. The leaf is always the last digit. Now, what do I mean by that? Suppose I start with the first one, which is 152, right? As the first number. Let me make it bigger. Okay. 16 or probably 18. Then I'm going to move it a little bit in. As a matter of fact, yeah, I think I moved it down a little bit so that we can have enough room. I think that's what I'm going to do. Give me 1 minute. So I want to show you how you can identify the stem. So now the stem, this is our data here. So I've put it in this form. Now I'm going to move it down to the next page so we have enough room. The stem is always, the leaf is always the last digit. So that means that in this case, you have stem, leaf. Okay, let me make it larger. So this one that I highlighted represents the stem. The last digit there is 2, and it is the leaf. See? This leaf is always the last digit. Stem is the remaining digit. Okay. So now we have arranged this in ascending order of magnitude. Now it is now to draw the stem and leaf plot. So to do that, now if you look at this leaf, this stem, you say 15. That is the first 2 digits is the stem here. And we look at all the first 2 digits here, you will discover that that they have this data set goes 15, 15, 15. I mean, when you look at only the first 2 digits, then 16, 16, all the way to 22. That, having that in mind, we help you to now create a table. So let me just, this have shown you how to identify the stem and the leaf. Now let's do the table. I mean the stem and leaf plot. So using this, I can now say, okay, this is my stem here. Excuse me. I can use it as my stem, leaf. Come on, leaf plot. So you go from 15, 15, 15, all the way to 22 when you are looking at only the first 2 digits. In that case, I can say that my stem, okay, let me see. My stem start from 15 to 22. So 15, 16, 17, 18, 19, 20, 21, 22. Now the leaf is the last digit on each of them. For example, the last digit, this is 152. So the last digit here is last digit will now become 2. That means this means 152. Followed by 153. So I'm going to put 3 here. Another 153. So I'm going to put 3 there. Then 156. 6. Oh, 6. Then 157. See? Next is 160. See? 160. And there are 2 of them, 160, 160. Okay. 160. Then we got 162. Say 162. You got 163. Okay. 3. Then you got a 166. So 166. Then 167. So you follow that process. 160, 160, 162. You know, just like that. The next one is 175. See, you have 17 here already. So all you have to put here is 5. Then you got 177. Okay. Got 178. Then 181. See, 181, 181. That means you have 18 here already. So 181 will be, you know, put only 1 here. You have 183. Then 186. Yeah. Then we don't have 119, but you have to put it there as a placeholder so that if there's any outlier, you will know. Okay. All we have, next thing we have is 206. So we have 20 here already. So 6. That means 206. And there are 2 of them. They got next is 228. We don't have 21, but we have 228. Even though we don't have 21, you still have to put it there because you have to count 21 before you count 22. 228. So after that, you can now put your lines, the table, because this is the stem and leaf diagram. So you gotta put a line here, the column. Okay, and this is your stem and leaf plot right there. See? That's a stem and leaf plot. So how do you interpret this? You can see that let me start from here. We haven't done skewness, so let me start from here. From this display, we can conclude that, see the highlighted portion, that between 152 and 186, between 152, see, 152 and 186 species of birds were observed and counted by the majority of the bird watchers, because you can see the majority counted between that amount. Between
I have a question.
Yes, yes. Say it again.
Where you get the 218 from? I only see 228.
Oh, sorry, my mistake. That was a mistake. I should put it right here. It was 228. Yeah, that's it. That's it. That was an error. 228. So you can see the majority of them are concentrated here, from 152 to 186. So from that display, you can see that between 152 and 186 species of birds we are observed, you know, by the and counted by the majority of the bird watchers. Another way you can interpret this, you can see that this display show that in that year the bird watchers counted or spotted a minimum of 152 birds and a maximum of 228 birds. So that's another way you can, you know, interpret this. Any question on this? Any question? Okay, good. Now, you might get a display like this one. This question is based on the data set that are 3 digits. Sometimes you might have the one that have 2 digits, like this one, this type here. It says, at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown below. And the question goes, construct a stem and leaf plot to represent this data and then interpret it. So the first thing is to put them in order. Now I have 2. You can see that they are all two digits, except this one. So that means you have to make this one 2 digits by writing it as 02. See? So 02. Next is to find their stem and their leaf. We have 02, right? This may make it 18 in size. So in that case, there are 2 digits each. This becomes, let me write here, stem, leaf. Okay, this becomes your stem, the 0, and I'll highlight it. The leaf, remember, is always the last digit. The leaf is always the last digit. So this is your stem, and your leaf is this one here. 2. So that means for this one now, the stem is 1, the leaf is 3. For this one, stem is 4, leaf is 3. Having said that, we can now put them in the table form. So I'm going to create more room down here so we can answer this. So you have a stem, okay, and our leaf. Okay. Now we got if you look at only the first digits, you can see that it goes from 0, 1, 1, 2, 3, all the way to 5. So that means it goes from 0. This is 1, 2, 3, 4, 5. Then the leaf become, let me move this a little bit. So there's the leaf. Now we start count, say 02. You have 0 here already, so just write 2. That's end it. For this one is 13. We have 1 here already. So we have 13, that means 3 means 13. 1, 4, that's 14. That's it. That's the end of that one. Next is 20. See, 2 here is already. We have 2 here, so you have put only 0. That's 20. You have 23, 25, because we already have 2 here. So it means 2, 5. They have next is 31. Have 3 here already. So just put 1 to make it 31. 32. Have how many of them? 1, 2, 3, 4. 4 32s. 32, 32, 32, 32. Then we got 33. Because we have 3 here already. 33. 36. Next is 43. We have 4 here already. So all you have to do is put 3, making it 43. Then 44, 44, 44, 44, 45. Then next is 51. We have 5 here already. So you have to put this 1, making it 51. Then 52 and 57. 52, then 57. Now, next, after having this, you can now put your line to complete the stem and leaf diagram. Okay. Then you have your stem and the leaf. So how do we interpret this? Okay, you can see that from here. Let me show you highlight the first interpretation so you can see it clearly. It says this stem and leaf, when you look at it very well, you can see that it shows that for 7 out of the 20 days, because this is for an outpatient center. So the number of cardiograms performed each day for 20 days. So you can see that for 7 out of the 20 days, they performed between 31 to 36. The number of patients receiving cardiogram was between 31 and 36. See? 31 to 36. That's when they perform most. But generally, this shows that here, it shows that the outpatient center actually treated a minimum of 2 patients and a maximum of 57 patients. That's the that one is better interpretation. Any question on this?
No.
Excellent. Now you can when you get a chance, you can try this one for your practice. Let's go to other types of the rest of the charts. Looking at the see the pie chart. Pie chart is a circular graph, and pie chart is based on this principle. The principle that I'm calling the theorem that the sum of the angles of a circle equals 360 degrees. That is the theorem that it is based on. But the good thing is that we'll be drawing this with Excel. I mean, the technology have come to stay. So the best thing is the best option is to make use of it. So that we can, I mean, when you're in office, being a manager, want to, analyze your data sets with in a pictorial form. You don't have to start drawing pencil and measuring degrees, angle. You have Excel, just put the numbers to give you the results. Then you can now interpret it. Okay. Now, our bar chart is another type of graph we're looking at. The bar chart, just like a histogram, I said that in a bar chart, the bars, there's a gap in between the bars. It's a gap in between the bars. Yeah. So those gaps, that's what differentiates the bar chart from the histogram. As a matter of fact, the histogram is a special type of bar chart. So in the bar chart, you can use it to say that there's a gap in between. Pareto chart is also a special type of bar graph, in the sense that in a Pareto chart, we arrange them in order from the largest to the smallest and then draw the graph. So the Pareto chart is a very powerful tool in the sense that it helps us to understand what factors must influence outcomes. It helps us understand what factors must influence outcomes. Yeah. So it is based on the Pareto principle. And according to that principle, 80% of outcomes arrive from 20% of costs. We'll get to that eventually. Now, so let's start with an example. Let's look at this question here. I'm going to move it down. We start with the pie chart. It says number of n degrees conferred in thousands in 2007 are shown below. It says use pie charts to organize this data. Okay? Use pie chart to organize this data. Okay? Let's do it. The first thing is to put the data set inside Excel. So I'm going to copy it. Copy it, Control-C, and put it in Excel. So I'm going to take you to Excel where I can put the data set. In Excel, Control-V. You can then arrange it. Okay? Or you can just type it in manually. Having put it in Excel. Next thing you do is to draw the charts. To do that, highlight this. Only the don't highlight the title. Don't highlight the title, just the data. Then click on insert. See the pie, this circle that represents pie chart right here. Can you see my cursor at the top? Hello, scholars. Can you see my cursor at the top?
Yes.
Okay, good. Click on it, then choose this one. Then it will give you other options at the top. Choose options that have numbers. See? Click on it and it will show you the pie chart. Then you can now add your titles. Okay. Oh, excuse me. I'm gonna add it. Title. The pie charts. This data set is for graduate. Let me go back to that question and in a word. This is for number of N degrees conferred. N degrees conferred in 2007. So this is for N degrees. And degrees in 2007. See? Now, next is to copy this and paste it in Word. I mean, if you are doing a project, just click at the charts here, then do Control-C to copy it. Then, and you can now paste it in your Word document where you are typing your project or whatever it is. So now put it here, Control-V is there now. And you can, expand it if you like, so you can see it better. Okay. Now, handle it up. You can see that majority of the degrees conferred we are for, see this is 51% is for bachelor's degree. I see the color here. Bachelors have orange color. Associate have blue color. See, blue color. So majority we are bachelor's degrees, 51%. Followed by associates. Green is for, I think green is for masters right here, it's 20%. Now, remember I told you that the pie chart is based on the angle, that the angle sum of a circle is 360. So suppose they give you the percent and they ask you to find, see, they ask you this question. Say, the question says, what angle does bachelor's degree represent? Okay, you can just answer it in this form. Bachelor's degree angle, you just multiply the percent with 360 equals bachelor's angle is bachelor's percent is 51%. I mean 51%. Now 51%, when you change it to decimal, you're gonna be 0.51. So you're gonna be 0.51 times 360. That will give you the angle it represents. So to do that, we can just go to the our calculator and then get the so let me see if I can. I think I opened too many pages and some of them disappeared. Just okay, let me see. The calculator, I think I have it now. So 0.51 times 360. 183.6. 183.6. 183.6 degrees. Degrees. So that the bachelor's percent represents the angle of 186.3 degrees. Any question? Ms. Key, what are you drawing inside? Hello?
Wouldn't it be an obtuse angle?
Huh?
Wouldn't it be an obtuse angle?
Obtuse angle, that's trigonometry. Obtuse angle, yes, it's an obtuse angle, but that's for trigonometry. Yeah. Any other question?
Could you repeat the question one more time?
Huh?
Could you repeat the question one more time?
You mean this one here? You mean this one? what angle does bachelor's degree represent? Is that the one you mean?
Yeah, because I was agreeing with Tremaine. I was also going to answer obtuse. So I just wanted to know what type of answer you were looking for.
Wait, it doesn't. So long as you have the percent. This is for bachelor's, right? If the percent multiplied by the 360, that will give you the angle. I'm not interested in the type of angle it is. Just to get the angle, correct. Like now, if I ask you what let me try it with a different degree. So if I say what angle does the associate represent, let me write associate here. Associate degree. Now in that case, associate degree and associate angle equals, angle equals, it equals, for the associate degree, you have 24%. That means 0.24. You multiply it, let me make it larger. I don't know why it's small like this. Multiply by 360 degrees. And that will give you the angle that it represents. Yeah. So 0.24, right? 0.24 times 360. 0.24 times 360. Okay.
86.4.
86.4?
86.4.
Okay, 86.4. 86.4. 86.4 degrees. Okay. So that's how you can answer question. And if they give you the angle and they want you to find the percent, you just divide it by the 360 and you get the percent, multiply by 100. So that shows you how to draw the pie chart. We can now look at the bar chart next. Okay, bar chart is a bar diagram, a bar graph, and this question says the heights of different breeds of dogs are shown on the table below, and it says construct a bar chart to represent this data, then explain our results. Again, what to do is to enter the data in Excel, and then you go from there. So I'm going to highlight this. Okay, copy it, put it in Excel. Okay, all right, so right here. I'll put it right here. So with this, I can now draw the bar graph, bar chart. Next is that when you highlight it, don't highlight the titles, don't highlight the breeds, just the data sets. Click on insert, choose the correct bar. You can choose, if you try any chart, if it doesn't work, like if I try this one, this one just give it to me right away. So but sometimes when you try a chart, if it doesn't work, you try another one. Another one. Let me give you. Yes, I think somebody just came in. Okay. You just give me 1 minute. Who is this person? Said a chair. A chair. I have this name. It's a key of a chair. Let me write this person's name. She's not in my list. Rachel. Zakia. Okay, it's present. Okay, now I can now adjust it. Put the titles. Click on this plus sign. Let me make sure I see this. Okay, on this plus sign, click check axis title, and it will give me the title. So now this is for height of breed of dogs. Here you write the breed. The breed. Okay. then the height in centimeters here, height. In cm. Okay. Heights of breed. Give it a title, a befitting title. Heights of breeds of dogs. Now, I usually like to remove the grid lines. Like this line, if you look at here, this grid line, just click on it, then press the delete key. It will remove the grid lines. Okay, is that gone? Now I can copy this. Click on it, Ctrl+C, then copy it, go to your Word document and paste it. Okay. And remember, if this is Excel assignment, don't paste it in Word. Just leave it, submit as an Excel file. Now you can even make it bigger if you like. And then, so you can see that according to this diagram, you can see that the tallest is the Fox Terrier, smallest is Chihuahua. Any question on this? Any question?
No.
Excellent, excellent. Okay, now let's go down to next graph. You can try this one by yourself as a practice. Draw a bar chart on this. Okay. So we are ready to now to do the what it called the Pareto chart. Pareto chart, which is also a bar graph. But in a Pareto chart, you arrange them in order first, from the largest to the smallest, before you can graph it. Look at this question here. It says, the table below shows the number of pounds in millions of pounds of each snack food eaten during a Super Bowl. So you can see the snack type: potato chip, tortilla, pretzel, popcorn, snack nuts, and for the pounds eaten. This one was 11.2 million pounds consumed. Tortilla was 8.2 million pounds, and so on. So construct a Pareto chart for this to present this data, and then interpret your results. Again, the key is to put it in Excel. I'm going to copy this and then go to Excel. But because of the shape of the table, I'm going to put it in a different Excel workbook. I'm going to put it on this one. Click here and Ctrl+V, paste it right there. Now you can just highlight it. Start from the potato chip and highlight. Remember, don't highlight the title. Once you have that, you can then draw. Click on Insert, and then choose the correct diagram. If you choose it, it doesn't work. I choose this one. See, this one doesn't work for me. It doesn't work. So I'm going to remove it. Click on this and delete it. So I'm going to choose the one that works. Suppose I go to the recommended charts. Even this one here. Let's try this one. This one worked. So I'm going to use it. You can see the Pareto chart, they arrange in order from the largest to the smallest. I can click on the plus sign to add the titles. So this is a snack. Snack. Okay. Millions of pounds. Pounds. Consumed. Okay. In millions. Now, this is Super Bowl snacks. Okay. Super Bowl. Oh, excuse me. Super Bowl snacks. Okay. Now I can just remove the grid lines, click on it, and then press the delete key gone. Then I can click here, Control C to copy it, and I can just send it to my Word document and do Control V to paste it. Now I can if you like, I can expand it. You can see that according to what we have, the most popular snack consumed during Super Bowl is potato chips, followed by tortilla chips. The least popular is snack nuts. So if you have a grocery store or all these big grocery chain like Walmart, they know that they have to stock up more of potato chip and tortilla chips than snack nuts during Super Bowl. Yeah. So this can see that's how you use statistics to make decisions based on data you collected. Next is the time series graph. Before that, any question on this one?
Outside is also on it.
Any question on this one? Hello? Hello? Can you mute yourself, Miss Chantel? Chantel Brooks, can you mute yourself, please?
And then what temperature did you want it off?
Miss Brooks.
Yeah, and then
Miss
the
Brooks.
light that you turn off, that's
Miss Brooks, can you mute
just so
yourself?
you're aware, this panel is also on right here. And then the volume is also adjustable in the
Hello,
right
Miss Brooks.
Okay. And this foam roller is for your cool down at the end to make sure it stays against wooden foam.
Miss Brooks.
That's where the use.
Yeah, I moved. Yeah, myself. Okay. All right. I muted her myself. So anyway, any question before we continue, guys?
No questions.
All right. Let's look at time series graph now. Time series graph will be the last graph we'll be looking at before we now move to data description. The time series graphs is used to represent data that occurs over a specific time period. That means data that are indexed by time. So good example is things like what we have here, which is subscribers, cell phone subscribers from the years 1998 to 2008. So the table lists number of cell phone subscribers for the years 1998 to 2008. You can see that this data is, they are indexed by time. So like you can use time series data to, graph to either to analyze them or to, or to present them. So let's do this one. It says, construct a time series graph chart for the number of cellular subscribers. And of course, you can interpret it. So what we do here is to put the data into Excel. So we can highlight this from here down. Okay. Highlight from here down, and then you can go to the Excel and paste it there. Let's go to our Excel sheet and then press Control V. It's there now. Okay. Now you can now draw the graph, time series graph. Highlight it, or let's highlight it here. Remember, don't highlight the title, just the data set itself. Insert. Let's try this line graph here. Because the line graph. Now, this one does not work for us. Why? Because remember, we have year in the horizontal axis, but what we have here is 1, 2, 3, 4. That's not what we want. So we can't use this. You can use it if you have the time to start making adjustments to it. But I don't have the time. So let's just choose the right one for it. Click on Insert again. Go to this place. Click on this, choose this one. See, this one worked for us. Okay. Now you can see that we have years here now instead of numbers. From 1990, actually 98 to 2008. So now you can now add the titles. Click on this plus sign, then click on add these titles. You can see that we have here is the year. Then subscribers. Subscribers in millions. Okay. Now you can now remove the grid lines. I can remove the grid. I can click here and then press the delete key. This one is gone. I can click here. This one is also gone. This could be cell phone subscribers. Subscribers by year. Okay. Now I can click on this here, do Control C. Go to the Word document where I want it to be, where the question was asked, and paste it there. If you like, you can expand it. From this, you can see that it's an upward trend. More people are having cell phones. As a matter of fact, many people these days don't have landline anymore. They have cell phones. Cell phone have become so popular. Even some people work with cell phone. Like those are these delivery drivers. Those are like those that deliver for DoorDash. What's the names? What their names? They use cell phone to receive the order in their cell phone, and then press a button that will put that will activate the GPS, and then they go and deliver. So naturally, people doesn't want to have. Some people don't have. They have cell phone and they're good. Like I can see that it's trending up. So according to this graph, the number of subscribers have been increasing since 1998, with greater increases recently. So let's conclude charts, graphs and charts. How to present data using graphs and charts. Okay, we started this last week and then concluded it this week. Now we can now look at what is called shape of distribution. The shape of distribution. If you have any question, please ask me here. I'm here now with you. I don't go to chat rooms when I'm teaching. If you have a question, instead of sending me a chat, ask me here. I'm here to answer any question you ask. Okay? Anyway, some distribution have what we call.
Excuse me.
Yes.
Yeah, sorry, I came into the class late because I had to go pick my daughter up from the hospital. Please, can you send this video after the class, please?
Yeah, as a matter of fact, I wanted to do that last time, but the video was corrupted. Yeah, yes, of course, I'm gonna post it on the announcement.
Okay.
I'm going to put the link on the announcement after the class.
Thank you so much.
So probably a few minutes after the class, because you have to, when you finish making it, you have to make it uploaded in YouTube first before you can now send it out.
Okay.
Yeah, so I'll do that, no problem.
Appreciate it.
Also, if you go to YouTube, type my name, first name Joseph, last name Oji, you see all the videos I made in this class for each different topics. So you can always watch them anytime you want.
Oh, okay, thank you, sir.
Oh yeah, sure, you're welcome. Now, under the shape of distribution, we're looking at this. Some distributions have humps or peaks that we call modes. I'm sure you must have heard the word mode before. Humps or peaks that we call modes. Okay. Now we have, if you look at this data set, I mean this bar graph, you will see the hump right here. Let me show you. You will see the hump that I'm referring to right here. The tallest bar there, the hump. And that means I have one of them, only one of them. So we say that it is a unimodal distribution because it has one mode, one hump or one peak. Call it unimodal distribution. Okay. Unimodal has one hump. And I'm going to show you a real life example of this. Let's say that, you know, in restaurants, McDonald's, for example, the volume of sales in the morning, yeah, maybe people go stop by in the morning while they're going to work to buy coffee or something like that. But sales increase significantly during the noon time. It goes up very sharply. See, number of meals sold. And I can make it bigger so you can see it properly. See, it goes up in the noon time. See, up. This is 1 p.m. See, it goes up. Then after that, it slows down. That's one example. So now that's a good example. Another example is this: sales volume during seasonal sale during Christmas. You know, after Thanksgiving, sales goes down, but now goes up again during Christmas. After Christmas, then it goes down. So it becomes highest during that Christmas sales. Then after that season, it goes down again. That's a good example of unimodal distribution. Now, how about this? Bimodal, you can see the two humps right here. The first one and the second one. Let me make it bigger so you can see what I'm talking about here. Okay, see the tallest two humps. We call them this type bimodal because you have two humps. Bimodal distribution. Okay, bimodal distribution. See, because it's two of them, this and that. More examples like Walmart stores. Walmart have sales during July, 4th of July, and then November during Thanksgiving. These are the 2 months that sales goes up. But you know that most distribution actually have multiple modes. Like this one have multiple modes, multiple humps. We call that type multimodal distribution because there are multiple modes. If you look at the stock market graph, stock markets, see the graph going up and down. Sometimes it goes very high, then down, then up and down. How about this? Your blood sugar. When you eat breakfast, blood sugar goes up. Then, of course, you're active, it goes down again. You eat your lunch, it goes up. Then goes down again. Then you eat your dinner, it goes up. So you see you have multiple humps, call it multimodal distribution, as you can see from this graph. This, that. Okay. Any question on that? Any question?
No questions so far.
Excellent, excellent. Now, you can now look at other concepts that we need to know, which is uniform distribution. Yes, you can have that. It might sound strange that we have a uniform distribution. So a good example. Suppose that you are doing a survey, and I mean, I have seen many online surveys that they say, okay, if you participate in this survey, you're gonna win a gift card of $50 or $25. You know, suppose we have that, right? Everybody that participated in that survey, everybody that participated will win $50. I use $25 here. That means the first respondent, this respondent will win $25. This one, $25. Anybody that participated in the survey will win $25. You can see that the bar will be uniform in height. We call this type uniform distribution. Uniform distribution. Okay. Which leads us to the next thing, which is skewness and symmetry. Skewness and symmetry. Okay. Now, let's start with symmetry. Okay, let's start with symmetry. A symmetry distribution is the type of distribution in which the data values are uniformly spread or distributed about the mean. If you look at this graph here, this center, assume that this one represents the mean, okay? Assume that it represents the mean, okay? We have, then we can see that they are, you can read it from here. Let me show you something. Let me show you what I mean by that. From here, from this line here, you can literally fold the left side into the right side. Just like your body, halfway, you can, it looks the same on both sides. We call it bell-shaped distribution, or I can call it symmetric distribution. Okay? So such distributions are bell-shaped, have a single peak, see, have one peak, and tapers on both ends, see, tapers on this side. Okay? I can give you an example of some variables that can be modeled using this kind of distribution. If you have a line graph of that type, it will look like this. See, the one I have here is for the distribution of pizza delivery times, right? You can see that it go between 15 minutes to 45. Let's say that in your neighborhood, you order a pizza to be delivered to your house. Usually, within 30 to 15 minutes to 45 minutes is normal delivery time. Above that, you're like, what is going on? So, because it's above, and even the pizza store, the pizza restaurant, if they believe that they can't get to you within 45 minutes, they will tell you, oh, we don't deliver in your area. See? Because it's within that range of 15 to 45 minutes range. It's normal, it's constant normal. How about this? Yeah, blood sugar. Now, if I plot, okay, let me use height. If I plot the height of, in this class, I have how many students? I have about 30 students in this class. If I plot the graph of this, the histogram, or line graph, histogram, maybe it's an histogram. It won't give me something as smooth as this because of sample size is very small. But if I plot the graph or the bar graph of all the students enrolled, the height of all the students enrolled in Morgan State University, it will give me something like this. A smooth curve like this. Small bars, bar graphs that if I put a line graph on it, it will give me something like this. So many distribution can be modeled using this. Yeah. So you say it's symmetric. Now let's look at skewedness. Some distributions are not symmetric, some are skewed. Look at this. Skewed. This one is right skewed. Why do I say that it is right skewed? Because if you put a line, you can see that it stretches more from here. It stretches more on the right side, whereas on the left side is basically a drop. See, a drop, but it stretches more on his side. So you say that it is right skewed distribution, and the line graph will look like this. Now, many real life variables are right skewed. I'll give you an example. Good example is income. If I plot a graph of income versus the population, like if I use this side as the income, this side the population, right? You see that we have more poor people than rich people. In fact, we have more middle class and lower class than the upper class. You see that more people will be located on this side as people with low income, but the billionaires will be on this side, because their population is lower compared to the middle class and the lower class, right skewed. Now, I can give you another example of this. Suppose I give you a test, and the test is very difficult, very challenging. You see more people scoring 30, 40%, and very few people scoring 90. Okay, this is right skewed. Now, let's look at the left skewed. Same thing, but now it is stretched more on the left side than on the right side. So, a good example, you can look at the graph. If I give you a test that is easy, everybody will be scoring 90s, right? They'll be on this side. Only a few people will score 10%. Yeah. Now, which brings us to the outliers. Outliers are like values that are a standard from the group. They stand out from the group. We call them outliers. I'll give you an example. If I take you to take any of you here to the second grade classroom and give a math test on second grade level math test. You put you as in a second grade classroom as a student. Your score will be off the chart because you know second grade math test is anybody. I mean, you will score 100 over 100 on that, but the students in the second grade class will be struggling. So you'll be an outlier. You can see how we show it on a graph. See, there's a gap here. See, it's standing out. Another example is if you're a millionaire and you live in a neighborhood that is mainly inhabited by lower class people. For example, a millionaire living in North Avenue will be an outlier, definitely. And so on and so forth. And we can even have two outliers, say on left side and right side. So this concludes the shape of distribution. Any question, scholars? Any question?
No questions so far.
Excellent, excellent. Now I can let me introduce you to the data description. Okay. Now I'll take you to data description. I'm gonna open it. Data description. Okay, and then close this in. So we collect data. I've shown you how to last week and this week I've shown you how to present data using graph. Now, how to describe data. We'll be looking at 4 measures here. Measure of central tendency, measures of variation, measures of position, and of course the exploratory data analysis. Let's start with the measure of central tendency. They are so called because they describe the center point of a data set or distribution. 4 measures we'll be looking at here: mean or the average, median, mode, and mid-range. So look at the mean. Mean is, as the name is at the average of distribution. So we can just say the average age of students enrolled in this class, or we can say, okay, let's find the average height, or let's figure out the average gas prices in Baltimore City. That'll give you an idea of how we can use mean. Median actually is the middle value of the distribution. Okay, for example, if we say that the median income of college professors is 65,000, what does that mean? 65,000 a year. It means that half of them make 65,000 or less, and the other half makes 65,000 or more. That's what it means, So now, which brings us to the mode. Mode is the data set that that occurs most often. Data that occurs most often. That means with the highest frequency. So the data value that occurs most often or that have the highest frequencies, the mode. Sometimes we use the mode, as a measure of popularity that reflects central tendency. For example, we can say the most preferred stock. Today, the most preferred stock, it looks like NVIDIA. They make I think they make chips that we use in most many AIs. Even you can even say Amazon. Amazon can also be the modal stock too. Because Amazon people, a very well-loved stock. The most preferred washing machine, the most popular presidential candidate in 2020, I think it was Trump. No, before 2020, it was Trump. That's why he won Hillary Clinton. Then 2029 Biden becomes the most popular and he won. Then early part of this year, it was actually Trump. Then they changed Trump. They now Biden now the Democrat forced Biden out, and then Kamala Harris, who used to be not. I mean, nobody even hear of her that much. And as far as I know, I'm a statistician and I'm also an economist. Kamala Harris doesn't really know much about economy and governance. Because remember that time when you asked her a question, she started laughing, you know. But the Democrats brought her out, polished her very well, probably gave her some, you know, coaching. She's not the most popular candidate. And that means she's the mode when it comes to, for now, at least. If you check the poll numbers, I guess what I'm trying to say here is that right now, she's very popular presidential candidate. So she's the mode. That will give you an idea of what mode is. The data value that have the highest frequency. So we can use it as a measure of popularity. Anyway, I think you get the point. When there's one mode, we call it unimodal. Two modes, bimodal. More than two modes, multimodal. Next is the mid-range. For mid-range, is just a rough estimate of the middle value, and we can calculate it we often calculate it using this formula here: minimum plus maximum divided by 2. Okay, and so this is the formulas we use. Sorry, the symbols. For example, this mu represents population mean, and X bar represents sample mean. You can see this symbol here, sigma. It means the sum of. So get comfortable with this because you'll be meeting all these symbols from now onwards. And now I have explained the measure of central tendency. Let me explain the measure of variation. A measure of variation, they describe how the individual data values have strayed from the mean. For example, in a highway, if the speed limit is 65 miles an hour, that's the average speed limit, and you're going 70 miles, that means you have strayed from the average by 5 miles per hour. If you're going 60, you're strayed. So if you're going 70 on a 60 miles an hour, I don't think the cops will stop you because you didn't stray too far. But if you're going 100 miles, that means you have strayed too far away. That will become, noticed. So how far data values stray from the mean, that's what the measure of variation tells us. Okay. So there'll be 4 measures of variation we're looking at. Have the range, the variance, the standard deviation, and the coefficient of variation. Okay. Range is the easiest to calculate. Maximum data entry minus the minimum data entry give us the range. The one we use mostly is the standard deviation, but we need to calculate the variance before you can get a standard deviation. The one we call coefficient of variation is well loved by stockbrokers because it tells us, we used to compare how a stock movement of stock price movement compared with the movement of the market index, market indices. And we can also use it to compare the cost of living in 2 different cities. The coefficient of variation. For example, somebody who got a job in New York City. Somebody who lives in New York City, doing got a job and lived there and was making $70,000 a year, and somebody who lives in Baltimore City and making $50,000 a year. They're almost the same thing because cost of living in New York City, cost of apartment alone is will take a big bite out of the 70 grand a year. So the coefficient of variation help us to compare this stuff like that, So now this is the computational formula for the measure of variation. The variance is sum of x squared minus sum of x squared over n. divided by the n minus 1. And the sample standard deviation is the square root of the variance. Okay? And for the coefficient of variation, we use the standard deviation divided by this mean times 100%. Now, I've explained all this. Now, let's start the work, showing you how to compute these measures. Excuse me. Before I do that, does anybody have a question for me? Any query? Any query or questions?
Not right now, no.
Excellent, excellent. Now, to start the computation, I'm going to open a new workbook in Word, because this one will not allow us to put some characters. So I'm going to open a new workbook in Word, and then I will go from there. Okay. So this will be okay. I think I have one here. Which one is this one then? I have one opened already. So I'm going to close this one there. So now let's start. Look at this question. It says, an experiment was conducted to measure the effectiveness of a new procedure for pruning grapes. Each of the 13 workers sampled were assigned the task of pruning an acre of grapes. The productivity measured in worker hour per acre is recorded for each person. See the productivity, see? 4.4 hours, 4.2 hours, 4.8 hours per acre, you know. They compute the following: the mean, median, mode, mid-range, and explain our results. The first thing to do will be to put the data set in table form like this. So I did. So I'm gonna move it to the next page so we can have enough room. Here, put it in a tabular form. So you can see the 4.4, 4.9. You can see them here, 4.4, 4.9. And use this X to represent all of them, which is productivity. Serial number, which is how many of them? I have 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See the 13 of them. Then add all of them. You can double check this with your calculator. Add all of them, you get a total of 59.3. So N is 13 because there are 13 numbers there. So put 13 for N. So next thing is this 59.3. The symbol we use for it is sum of. So I'm gonna go to that workbook. I'm gonna write this thing down. Where's my paper? Write this thing down. So we can compute this. We have N is 13. Okay, we've got 13 numbers there, and this is the productivity. Okay. Now let's get the sum of. Okay. So the other workbook we need, I closed it. Oh, I have to open it again. Okay, open it again. This is workbook right here. So let's put the symbols we use here. The sum of X. I'm going to make this to be bigger. I'll make it 18. Sum of X. We got this. Oh, excuse me, sorry. Sum of X. We have it on our workbook as when we added all of this. 59.3. Let me write this. 59.3. Like I say, you can double check this with your calculator. 59.3. So that's sum of X. 59.3. So I can just, copy this and paste it there. Okay. See? Now we can find the mean then. The formula for the mean is the mean, which we represent with X bar, use X bar to represent the mean. Okay, X bar are equal to have sum of X over N. Okay, it means sum of X, we have it here as 59.3 and our N is 13. Okay, so I'm gonna put it right there. 59.3 and N is 13. Equal. So we can now get it from the calculator. That means we got 59.3 divided by 13. 4.56 rounded, 4.56. Let me write it down, 4.56 rounded. So we can go and put it right there and then transfer it to our main workbook. 4.56. 4.6. So I'm gonna copy this and paste it here so we can now interpret it. Okay. So I mean right here. So when you finish calculation, you have to interpret your result so that to get the full credit. See, according to this answer we have here, the average is 4.56. You can see that the mean productivity rate of 4.56. Now, what does it mean? It means that the amount, okay, the amount, let me put this in a very simple way. The amount, the average amount, okay, of time taken by workers to prune an acre of grapes using the new procedure is 4.56 hours, 4.56 hours. Okay. So the average amount of time taken by the workers to prune an acre of grapes using the new procedure is 4.56 hours. That's what it means. Any question on this? No questions. Okay, excellent. Now, so we answered part A, we answered this mean. Now let's do the median. To do the median, we arrange the number data set in order from the smallest to the largest. See? In order. The median is the number in the middle. So here we got 13 numbers. So 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. That's 12. So 1, 2, 3, 4, 5, 6. So this number here. See? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the median is 4.5 because it is the number in the middle. 4.5 hours. Which means that half of the workers have a productivity, or half of them can, let me put it that way. Half of the workers, okay, let me put it this way. Half of the workers, okay, let me see. Half of the workers, the average amount of time, or half of the workers, okay, can prune an acre of grapes using the new procedure, okay, in 4.5 hours or less. While the other half can do it in 4.5 hours. Okay. In 4.5 hours or less. Sorry, or more. So half of the workers can prune an acre of grapes using the new procedure in 4.5 hours or less, while the other half can do the same thing in 4.5 hours or more. Okay? That's what it means. Okay? That's the median. So now next is we answer the mean. We answer the median. Let's do the mode. For the mode, again, we put them in order from the largest to the smallest. Now you can see that choose the one that have the highest frequency. You have this one, 4.4 occurred 3 times. And then 4.8 occurred 3 times. So then we have 2 modes, 4.4 hours and 4.8 hours. See? So that means that the modes of it is bimodal because it had 2 modes. Bimodal, excuse me. So according to this this answer, I see that the frequently occurring productivity rates when pruning grapes is 4.4 and 4.8 hours. So which means that these rates are the common benchmark for these stacks. Okay. Then last one thing that we want us to compute there is the mid-range. And it's said to interpret, explain a result. So you will notice that in each case, after getting the answer, I always interpret it. So that takes care of part A. So the mid-range. Mid-range means the largest number there, see, plus the smallest plus the largest divided by 2. For example, here we have the smallest number is, smallest productivity is 4.2. Okay, plus the largest one that we have there is 4.9 divided by 2. That will give us the mid-range. Remember, the mid-range is the rough estimate of the median. So the same way we interpret median is the same way we interpret mid-range. So mid-range for us, I got 4.2 plus 4.9 divided by 2. So let's get it answer for this. From our calculator, we have that 4.2 plus 4.9, okay, divided by 2. 4.55. So it is the rough estimate of the median. So I'm going to go there and put 4.55 plus our mid-range, 4.55. And when you look at our median, see, this is our mid-range. Okay. We look at our median, it's 4.5. See? And this one will give us 4.55. So if you're in a hurry and you want to calculate the median very fast, you don't have the time to start arranging the numbers, just get the mid-range. That will give you the rough estimate of the median. Questions on this? Any question?
No questions so far.
Excellent. Now, sometimes if you look at the one this one we did, where we find the median number, they are 13 in numbers. That means odd numbers. In that case, the median can be a single number in the center. It's easily to locate the median when they are even. When they are odd numbers. In some cases, there might be even number like this one. 1, 2, 3, 4, 5, 6 numbers. So you cannot see a single number in the middle. Instead, you see, after you arrange them in order, you see that there are 2 numbers in the middle, which are these ones. In that case, to find the median, you're going to add the 2. Median becomes 235 plus 268. Okay, divided by 2. I'm going to write this down. Median 235 plus 268 divided by 2. Okay, I have, then this you have 235 plus 268 divided by 2. Give me 251.5. So we go down and put it in 251.5. 251.5. So let's give us the median. If it's an even number distribution or data set. So let's give you a rough estimate. This give you basically how to calculate the measure of central tendency for ungrouped data sets. See, for ungrouped data sets. Okay. Now let's look at measure of variation. We look at how to calculate the variance, the range, the variance, and the standard deviation. It says the data below, or data on European auto sales for 6 years are shown here. These data are in billions of dollars. Say 11.2 billion, 11.9 billion, 12 billion, and so on. So calculate the following: the range of data sets, the sample variance, and the sample standard deviation. Okay, let's do it. Range is the easiest to calculate. Maximum data entry minus minimum data entry. Here, the maximum is 14.3. 14.3 minus the minimum is is 11.2, and that will give us the range. So range will be, I can do this actually mentally. 3 minus 2 is 1. Okay. Points. They got 4 minus 1 is 3. See? So that the range is 3.1. What does this mean? It means that European auto sales vary by a range of $3.1 billion over the 6-year period. Okay. Now, another question is they want to find the variance and the standard deviation. To do that, you put these numbers in a table form, a tabular form. Here, see, the first one is 11.2, 11.9, 12.0. This is their serial numbers. Number 1, number 2. Well, this is see right here. Number 1, number 2, number 3, number 4. That's the serial number. That's what it means. Next is to get the total of these numbers here. So let me write them down so we can get the total. We get 11.2, 11.9, 12.0, 12.8, 13.4, got 14.3. See, got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's go and get the total of this. I'm going to take you to the calculator to get the total. So you have to do to be able to calculate the variance, you have to get all these totals. 11.2 plus 11.9 plus 12.0 plus 12.8 plus 13.4 plus 14.3. 75.6. Let me write to that. 75.6. Okay. We go there and put it in. 75.6. Okay. Now, this is the formula for finding the variance of x squared minus sum of x. So the sum of x, we have it here already as 75.6. Based on our mass here of adding all these numbers. 1, 2, 3, 4, 5, 6. Yeah. So we need to get this part, which is sum of x squared. So to do that, we need to get our x squared. X squared. Okay. I am. Oh, excuse me. All right, let's see. All right. Okay, x squared. See, I got it here. That's center 8. So that means I mean to square all of this. Okay. Give me 1 minute. Let me get something from here. Let's make it to be. Okay, I got this right here. Oh, got it. So anyway, to square it. Now 11 squared, 11.2 squared. You gotta put it in a calculator. So clear this. 11.2 squared give us 125.44. Okay, 125.44. So you go and type it in there. 125.44. So following that method, I get the rest of them. I'm gonna type them in. 11.9 square. You can verify this. 141.61. Next one is 12 squared is 144. Everybody in Baltimore knows that one. 12.8 squared, I got 163.84. 13.4 squared, I got 179.56. Then 14.3 squared, I got 204.49. When we add all this, you're gonna get 958.94. Okay. And with that, we are ready to calculate your variance. Yeah. Now variance. Let's do it. Now, this is the formula here. Remember that n represents the number of items we have there. Our n here equals 6 numbers, because there are 6 of them. 1, 2, 3, 4, 5, 6. So our n is 6. Of course, it's more n. Okay. Now let's get sum of x squared and this. Actually, sum of x squared is this one. And sum of x before you square it is this one. So let me put them in the symbol the way they should be. Then we can now plug them inside this equation to get our variance. Yeah. Now let's get the sum of x first. I'm going to take you to that workbook. Let me write this down. Take you to that workbook. Sum of x is 75.6. And sum of x squared is this one here, which is 958. 958.94. Let's go and put them, the right way in the using the right characters and the right symbols. So sum of x squared. Now put this. Oh, sorry. This is sum of right here. Sum of x squared. Sum of x squared. Okay. Equal 958.94. Because remember, I showed it here, I showed it to you here. You can see the x squared. You can see the sum right here. See? I can see it, you see 958.94. And sum of x is 75.6. Okay. So you had a sum of x now. Sum of x. Okay. Equal 75.6. So I'm gonna copy this and paste it in our member book so you can see them, and then we can find our variance. Okay. See? Now we're gonna plug all these three things, 1, 2, 3, into this formula to get our variance. So I'm gonna copy this equation, paste it in that workbook so we can find the variance. Once you find the variance, the standard deviation is the okay, I'm gonna it's acting weird. Okay, so I'm gonna okay. Let's see. I'm gonna go back and copy this from there. I didn't copy it right. So I'll copy this, Control C. Go to the workbook and put it right there so we can get our variance. You know, when you're solving it on paper, you're using pen and pencil, so you won't be going through all these challenges of putting it in a computer. Do I do it? So variance will be sum of x squared minus sum of x squared by n divided by n minus 1. So sum of x squared minus sum of x squared by n divided by n minus 1. Okay, this will be equal. So I'm gonna put it here. Sum of x squared, we got it as if you can look at our book, it is 958.94, and sum of x is 75.6. Then n is 6. So let's go and put them in. So we got 958.94 minus you have this. Okay, sum of x, which is 75.6. Okay, squared over n. N is 6. Then divided by 6 minus n minus 1. See, n minus 1 means 6 minus 1. So I'm going to write this here so I will take you to the calculator so we can get it down. Variance 958.94 minus 75.6 squared over 6 divided by 6 minus 1. Let's go to the calculator and put this and then get our answer right there. Okay. So we have 958.94. Oh, excuse me, I gotta go up. Minus 75.6. 75.6 squared divided by 6. Then all of them divided by 6 minus 1. Yeah, that's what we have here. See? Divided by 6 minus 1. And what is the result of our computation? It says 1.27. I mean, basically 1.28 rounded. 1.28. Write it down. 1.28. So let's go and put it in. We got 1.28. So we're gonna copy this. It's a variance and paste it in our main workbook. Okay, that's a variance right there. So next is to get a standard deviation. Before I do the standard deviation, any question on this? Any question? Hello, guys. So there's no question again. Now remember.
No questions.
Good. Remember, in statistics, there might be up to 3 different formulas for finding an answer. Like this variance, there are up to, I think, up to three different formulas for finding the variance. I recommend that you stick to the one we're using in class so that you don't get confused. However, if you know how to use the other formula very well, you can use it. The answer will still be the same anyway. But since you're not because there are so many, we're gonna do so many calculations here, so many statistics, I mean to say. And if you are not, this time period we have only 18 weeks, might not be enough for you to memorize those formulas. So it's better to stick to the one we use in the class so you don't get confused. Anyway, let's get the standard deviation. The standard deviation is the square root of variance. You can see right here, square root of variance. Give us the standard deviation. Okay, our variance is 1.28. Let's go and get the standard deviation. We go to that workbook and I type standard deviation equal to be square root of variance. Okay, which equals the square root of 1.28. And that gives us excuse me, sorry. That gives us excuse me. Equal. Yeah. 1.28. The square root of that. That is 1.28. That is 1.13. 1.13. 1.13. And that will give us the standard deviation right there. So we can copy this. Okay. Copy it and then paste it right here. Under here. So we'll answer the question. We'll answer the range, variance, and standard deviation. Now, you see how long this took us? We can remember you'll be doing Excel assignment in this class. So I'm going to show you how to do all this in Excel. You can see that you can get all this in faster in Excel. So let's do this in Excel. And then I'll introduce you to the coefficient of variation. Okay. So let's do the first one in Excel. The first one says, remember here it says to find the mean, variance, standard deviation. Sorry, mean, median, mode, mid-range. So I'm going to use this example to find the mean, median, mode, variance, and standard deviation. Yeah. Let's do it. First thing is to put numbers in Excel. So I'm going to put them in Excel. So I'm gonna copy this here. Control C. Take you to Excel. Excel will now simplify the whole thing. For us. I'm gonna open a new workbook. So let me close this side because this side is okay. So let me put under book, Excel workbook. So I'm gonna paste this thing here. Makes the adjustments. Okay. So we are looking for, make sure I have everything. I want to calculate the mean. We need the mean. Oh, excuse me. Mean, median, mode, variance. Let's just do mid-range. That's what that question. That was what that question wanted us to calculate. Said mean, median, mode, mid-range. And if we want to get the variance, we can also get the variance from here. But let's answer what the question says. Okay. So we have this here. And then you make it bigger. Okay. So in that case, mean, before you do any math in Excel, you have to put the equal sign to put that cell in ready mode. So you put equal, find the mean, put equal sign first, then type mean means average. Average. It will pop out. Double click on it. Highlight all the numbers. Press the enter key to give you the mean right there. Make this 18. See? And you can see that when I click on it, it will show me the work you did here. Now, it gave you the answer in many decimal places. You can reduce it by just clicking on this icon here. Shall I call it an icon? Just right here. If you click on it, it will decrease 4.56, which is the same thing, same answer I got when I did the mean right here. 4.56. You can see it right there. See? Now, next is median. Equal. Type median, MED. It will pop out right here. And again, highlight all of them from this number to the last number. Press the enter key. Give me the median. I'm gonna okay. Which is the same thing that I have here. For median, 4.5. Okay. For mode, this Excel acts funny when it comes to mode. So sometimes if it's by mode, 2 modes, it might give you only one of them. Anyway, to find the mode, use the formula here equals MODE mode. Double click modes and then highlight all of them. Press the enter key. 4.4. So you give me one of the modes. Okay, only one of the modes. But I know that it's more than one. It's 2 modes. I say it can be like that sometimes. Let me see if I use the other command. If you go equals mode. Okay, double click on the mode dots. Mod. That's a multimodal. Maybe that one will give us the second one. Okay. Highlight it and press the enter key. Yep, it gave me the 2. See? So it gave me the 2. If you suspect that it's a multimodal, see, I tried it, gave me the 2 modes right here, the 4.4 and 4.8. Which is exactly what we have here. 4.4 and 4.8. Yeah. Now let's look at the mid-range. Mid-range is the smallest number plus the largest number divided by 2. In this case, the smallest one, I'm going to put parentheses here, make it for the order of operation. The smallest number is 4.4. Sorry, 4.2, I believe. And plus, the largest should be 4.9, I believe. Yep, that's what it is. Okay, close the parenthesis, divided by 2. Okay, let me actually make this. For this side is showing it is 11. Okay, good, that's better. Equal. Put parentheses first. Click on 4.2, the smallest. Okay. 4.2, the smallest, plus largest is 4.9. Click on it, close it. Then / is the division symbol in Excel by 2. When you press the enter key, it will give you the answer for mid-range. 4.55, which is what we have when we calculated the mid-range here. See, 4.55. Okay. Now for suppose we want to find the variance here. We want to find the variance and the standard deviation. Okay. Suppose we need that. Just type, put the equal sign, type, let me make these cells to be 18. Okay. Just type the equal sign, type VAR dot S. Why dot S? Because it's a sample. If it's population, you use dot P. Double click, highlight all of them, then press enter key. It gives us the variance right away. Okay, it gives us to us in multiple decimal places. So you can just decrease by clicking on this place. 3 decimal places is good enough. And if you need the standard deviation, excuse me, just type equals STDEV dot S. Since the sample, it will pop out here. Double click and highlight. Enter key. Give it an answer right away. Which you can decrease the decimal places. Any question on this before I show you the other example, the other one?
No questions so far.
Okay, good. Now, I'm showing how to calculate mean, median, mode, variance, and standard deviation using Excel. Now, let's look at the last concept before we end for tonight, which is the coefficient of variation. Now, you can use that to this Excel to find the variance and the standard deviation for this, and you get the same answer I have here. So you can try that as a practice for yourself. And look at the coefficient of variation. The formula is standard deviation divided by mean times 100. And look at this question. It said the mean number of cells of cars, excuse me. The mean number of cells of cars over a 3-month period is 87. And the standard deviation is 5. The mean number of commissions is $5,225. And the standard deviation is $703. Compare the variation of the two and explain our results. Again, this is the formula here. Standard deviation divided by mean times 100. So for cells, we have this mean as 87 and the standard deviation is 5. So the coefficient of variation will now become will be 5 divided by 87 times 100. So let me write this down. CV is 5 divided by 87 times 100. Okay, you go to the calculator and get it down there. 5 divided by 87 times 100. 5.75%. 5.75%. Okay, let's go and write it down. 5.75%. Then we'll repeat the same for the commission. For the commission, where the mean is 5,225 and the standard deviation is 773. So that the coefficient of variation become 773 divided by 773 divided by 5,225 times 100. And that will give us the coefficient of variation. So we got, let me write it down. CV is 773 over 5,225 times 100. Let's go and put it in. We got 773 divided by 5225. Okay, then times 100. 14.79%. 14.79%. Let's go and put it in. 14.79%. 0.79%. So you can see that from these answers that we have here, for the cells, the coefficient of variation is this 5.75%, and the coefficient of variation for commission is 14.79%. So that means that since the coefficient of variation is larger for commission, it means that commission varies more than cells. Okay, it varies more than cells. Any question on this? No question. Excellent. So let's do the last one. Because the question on the coefficient of variation can be asked in different ways. This is the second way it can be asked. It said, sample annual salaries in thousands of dollars for entry-level accountants in Dallas and New York City are shown here for the year 2015. This is for Dallas. These are in thousands of dollars. Like this one is $41,600 for that year, you know. It said, find the coefficient of variation for each of these two data sets and compare the results. So the first thing is to put them in Excel. I'm going to use Excel. Or if you don't want to put them in Excel, then you have to find the mean for Dallas, and then the standard deviation for Dallas. Then find the mean for New York City and the standard deviation for the New York City. Then calculate this coefficient of variation. But to make it faster for us, we're going to use Excel. Let me write Dallas and put numbers there, which are 41.6, 50.0, 49.5, 38.7, 39.9, 45.8, 44.7. And for New York City, we got 45.6. I mean 45,600. Yeah. 41.5. 57.6. 55.1. 59.3. 59.0. 50.6. So let's go and put this in the Excel and get our answer right there. So I got Dallas. I just made these things to be 18 so we can see it clearly. Dallas. I have Dallas for 1.6. We got 50.0, 49.5. Okay. Okay, we got 49.5. Next will be at 8.7. At 9.9. 45.8. And then 44.7. Okay. Now for New York City. Okay, we have 45.6. 41.5. 57.6. Okay, 55.1. And we got 59.3. Okay, 59.0. Okay, 50.6. All right. So remember that what the question wants us to do is to find the coefficient of variation for each of the two data sets and then compare the results. If we look at this, so to find the coefficient of the variation, we need to find the mean and then find the standard deviation. Oh, so you know what? I put it in one place. I have it in one place. To find the mean. Yeah. I'll make all this side to be 18. Yeah. Mean they have standard deviation, then the coefficient of variation which is CV. I'll remove this. So yeah. Let's find the mean first. Find the mean. You can see this. Okay. The mean is equal. Remember, to do any calculation in Excel, put equal sign first, so that you put the cell, that cell in a ready mode. Mean find the type average. To pop out, double click, highlight all this, press the enter key. See? Now, you have done this, you can now copy the formula to the next cell. It will calculate this automatically. So we move this, see this cursor is tick. We move it here, it turns a skinny one. At that point, you click, hold, and drag. It will calculate the formula right here, see? See the mean for this Dallas and see the mean for New York. Repeat the same thing for the standard deviation. Equals STDEV.S, because this is a sample. Okay. Highlight this. Press the enter key. And then click on it and then drag it. It will calculate the standard deviation for the New York. Now for the coefficient of variation, which is actually what we are looking for, remember that the formula says that it is the standard deviation divided by mean times 100%. So to get it here, you put equal, the standard deviation is click on it, then / for division divided by this. Press the enter key. And then you can then copy it from here. So copy the formula, you calculate the rest. So now to change this to percentage, highlight those two and click on the percentage symbol right here. Okay. 2%, 10%, 13%. If you want you to have more decimal places, you can just click on this. Okay. Now you can highlight these ones. You're not worried about this because the main thing you're looking for is this, the coefficient of variation. You can see that salary in New York varies more than salary in Dallas because it have a higher coefficient of variation. Okay. Any question before we start for tonight? Any question? Hello.
No questions.
Question.
No questions. Okay, good. Don't forget
I have a question.
Yeah, go ahead, sir.
Where do we find the notes for this?
Oh, you want me to upload the note for you?
Yes, sir.
You mean this one, right? This one here?
The worksheet we've been working on. Yep.
Okay. So let me upload it from here. I should have saved it on the desktop. Yeah, let me save it on desktop. Let me see if I can save it on desktop. So I'm gonna clear all this. Let me save it on desktop first of all. Then I can upload it. Desktop. Plus, I'm gonna post this video so that you can also watch the video. Now I'll upload it. Let me see. What is the classroom? Okay, the classroom is somewhere here. Okay, give me a minute. Let me put the classroom. See a classroom right here. So, yeah, that's the classroom right there. So I'm gonna share it on the file. Upload this on desktop. Okay, it's right here. So you're gonna see it on module 3. I put it on module 3. Module 3, the file. Gonna be right here, the description. So it's right here, module 3. See?
Thank you.
Yeah. Then the video, when it's finished uploading, I'm gonna put it here for you in announcement so you can watch it as well. Now let me check. I've already checked all of your names, but I want to make sure I have everybody's name. I have checked most of the names here. There are some people that don't have the real name showing up, so I want to make sure. Coolman, I have Coolman already. Floyd, like here, Floyd. Yeah, Floyd. I don't have that name here. I'll write it down. Nakia Floyd, Nakia Floyd, like 28. Nakia. No, Nakia, sorry. Nakia Floyd. Okay, she's here. So who else? Who else? Gross. I have Gross. Harris. Yeah, I have Harris. So I have most of, yeah, I have everybody here for now. All right, guys, I see you guys next week.
Awesome. Thank you so much. Have a good week.
You too. You too. Have a nice night.
Take care.
Goodbye.
Thank you.
You're welcome.
Hello, Professor. Did you get me for attendance?
What's her name?
Thompson.
Yeah, I did.
Okay. Thank you.
Thompson, don't tie, right?
Yes.
Yeah, I got you. What's your name?
All right. Thank you. Take
Bye.
care.
You too. Happy to see you guys next week.